This is lesson 5, finding the intercepts of a linear function. And we'll complete this lesson by reviewing 3 questions from your assignment 5. And the 3 questions are focusing on solving problems involving the x and y intercepts of a linear function, and also looking at the limitations of the x values and the y values in contextual problem. So there are 3 contextual problems we will look at, and we'll find out about how we go about solving each one. So for this one, you'll need your graphing calculator or Desmos. So those are 2 things you may want to be handy with you. So I'll zoom out a little bit so you can see. So we have a graphing calculator as well as Desmos. I'm using my phone. Also, you may want to have your instruction sheet handy if you haven't memorized all of the steps by now, but I'll walk you through each step nevertheless. And the one along with Desmos. So we'll be looking at the questions from assignment 5, and there are 3 questions we'll be looking at. Questions 3, just remember the previous lesson we looked at sketching the graph of each function from questions 1 to where there are 6 parts to it. We sketch the graphs and label all intercepts. And question 2, we looked at the characteristics of the equation of a linear function. So we said we have leading coefficient, y-intercept, end behavior, slope direction, x-intercept, domain and range. Now, some of you are still wondering about domain and range. Just a caution. If there is no restriction, if ever you're given an equation and there is no restriction given, then the domain would be all the x values that are real numbers, or from negative infinity to infinity. So, for example, this equation, y is equal to 6.28x plus 1.57, there's no restriction given to this function. So if there's no restriction, then you can conclude that the domain is from negative infinity to positive infinity. The same would apply to the range. There's no restriction here, so the range will be from negative infinity to positive infinity, or y is a set of real numbers. Meaning that there's any number you can think about this graph on, and the range referred to the y values. Just remember, right, your range, let's say, for example, I have a graph going up by that. Now the range referred to my y values, from how the lowest point to the highest point. As long as there's an arrow head on both sides, it means it's going on to infinity. So this is positive infinity, negative infinity for the range. So this would be the range. And it's always from the lower to the higher points, negative infinity to positive infinity. So you can write a negative infinity. And it's always written in a smooth bracket. Now the range is the y values. Now the domain refers to the x values. So the domain now we'd be looking at from x to x. So this is from negative infinity, which is this end here, to positive infinity. The next few questions, we are going to be looking at restrictions, and that's where I'll show you how to write whenever there's the range and the domain whenever there's a restriction. So this is on page 28 and 29. We'll be looking at these 3 questions. So question 3 Okay. See, a hot air balloon is flying at an altitude of 1,236 meters. It begins descending at a rate of 10 meters per minute. The balloon's height from the moment it begins its descent until it reaches the ground is given by this function. So this is the function here, y is equal to where t represents time in minutes since the descent began, and h represents the height. Okay. And you have a series of questions. Sketch the function. What does t represent? What does h represent? How does the h intercept? What does the h represent? Sorry, what does the h intercept represent? What does the t intercept represent? How long does it take the balloon to reach the ground? Does the graph continue in both directions? Explain what is appropriate range for this problem. And this is where we'll talk about the restriction and the domain and the range. Now, whenever we're given an equation, and notice this is an equation of a straight line or a linear function. We know the equation of a straight line is y equals mx plus b. Remember, your m is your slope, the number in front of the x, and your b, the number with nothing beside it, you refer to the y-intercept, where it crosses the y-axis. So 1236 is where this graph crosses the y-axis. So we'll do a sketch of it first. Okay. First of all, sketch of the graph of this function. But to sketch it, we need to interpret what this h and t represent. Now the h would be like your y. So we can make this a y. I'm going to write it back here. -10. And your x is like your t. And your b would be 1236. Well, we will not use y and x. We'll use h and t. So that's what's given. So we replace, now this is your y-axis here. This is your x-axis here. Now this is already given to you. So we know we're starting off, this is a Cartesian plane 0 here. So now this is your restriction on your range and domain. Because you cannot go below ground level and you cannot go back in time. If you were to have a negative here, say -10, you're going back in time. Because it tells us that t, which is your x now, this is your time. And it represents in minutes. So if you were to have a negative value here, you're saying going back in time, and that's not realistic. In quantum physics, you probably would go back in time, but not in this question here. You cannot go back in time. You cannot go back before you started. So that is why your domain here, now your domain refers to your x-axis. So this is your domain. So where am I starting from? I'm starting from 0. So my domain, if I were to write that here, which is my x values. So where on this graph, where the x-axis graph exists, it will be from 0 onwards. Now, we have to figure out our domain, or extent, how far we should go. So domain, we know now, is from, now a square bracket like this here tells me it begins from 0. Now, if it didn't touch 0, then I'll have a smooth bracket. but because it touches it, we'll have a square bracket. Now, we are going to end somewhere. I don't know where it's going to be, but so we're going to figure that out. Your range now, I'm going to start from 0 now, going up. So my range is also starting from 0. Where it ends, we will discover it. And we'll have to stop at a point too, right? We can stop there if you want. We can stop here if you want, but we'll determine that afterwards. So for those of you who are wondering about domain, it didn't ask you for the domain here, but I tell you, ask for the appropriate range. So now we have time. Let's go back to our graph. So time is t, right? So we can replace this x now with t. It's time. Now, your y-axis is height. So we get here height. And the height, it tells us here, represent height in meters above ground. So this is above ground. So this is ground level. 0 is ground level, if you want to put it here. So this is our ground level. We cannot go below ground level. So that's why my range now starts from 0, which is in meters also. So we're still sketching our graph. Now, what does t represent? It tells us here t represents time. So time in minutes. We'll put that in here. And h represents height. And it's in meters. So time. Now, we'll do the rest later when we have a graph. Now, sketch the graph of this function. Now, to sketch a graph, this is where you need a graphing calculator. You need a graphing calculator here now. Or Desmos. Or Desmos. So use. So we'll use a graphing calculator. So I'm going to show for both. Now, I'm going to clear my graph, make sure I have nothing in there. Okay. I'll clear this now. Also use Desmos to get my graph. Now notice, the calculator doesn't have h, right? So we'll use y. So replace the h with y and the t with x, and the rest will be the same. So now we translate the functions given, h equals negative 10t plus 1236 to y is equal to negative 10x plus 1236. So we'll enter into our graphing calculator, and Desmos takes the equation of the below the given one. So let's put that in there, negative. So remember, when we have a negative, you always use this negative sign here, negative 10x plus 1236. Now, notice on my y-axis here, the minimum is 1236. Okay, so we should have at least 1300 up here. Now, we don't know the t yet. Okay, so we'll figure that out. We can do a guess right now. I can make it maybe 100 here. Okay. I'm just doing an estimate right now. Because I need to go, when I go to graph, what do we have there? Normally you will see this. Okay, right now my calculator is working. You won't see anything. Or you go to a standard, you will not see any graph. This graph doesn't seems to exist. So we have to set we want our window to look like this from 0, or minimum for y is 0, maximum is 1300. And for x-axis, we want a minimum to be 0 and a maximum to be 100. That is why you want to do a sketch. Give you an idea what your graph would look like. So right now I have this 0, 0, I have -10, negative for x, -10 for y. But I don't need these because I cannot go back in time and I cannot go below ground level. So I go to my window and I let my x minimum be 0. So I'm starting from. And my x maximum, I'll make that 100. Now I may adjust it depending on how my graph look like. Then go to my y minimum. I'm going to get rid of put 0. I'm starting from 0. I'm going up to 1300. Okay, go to my y maximum, make it 1300, which is above what's given as your intercept. Press graph, and notice your graph shows up. Notice I didn't extend enough on my time. So I have 100 here. So this balloon will intercept the y-axis beyond 100. So now I have to go to my window and change that now. Maybe put 150. There you can see your graph. Now we need to find our y-intercept and x-intercept. Now we know from there our y is 1236. So we know, so we can do a scale here, the 1300. So we have 100, 200, 300, 400, 500, 6, 7, 8, 9, 10, 11, 12, 13. So we have, so remove this here. Those have them on equal increment. So start from 0. 100, 200, we have 300, 500, 700, 900, 1100. And for here now, I'll make these an increment of 20, right? 20, 40, 60, 80, 90, oops. Wait, come to 20 here, 100, 120. Okay. So that's what I don't know exactly the point on the y-axis. Let's fill anything here. What does the h-intercept represent? Now, in other words, what does this h-intercept represent? So let's find the h-intercept or the y-intercept in this case, right? Now to find the y-intercept where it crosses here, we know it's 1236, but we can do that right now here. But let's prove it, okay? Let's prove that. So we go to find your, by the way, you can go to your, on this here, y-intercept. You can enter y, which we did, second trace value, and choose x as 0, and you press enter. So let's do that again. So we already have our equation. So we go second trace, press enter, I keep it there. Let x be 0, y is 1236 exactly as this. So now right at this point here, 1236. We don't know our x-intercept. And this is what we're going to do now. To find our x-intercept, we're going to use this instruction here. Okay. So what we'll do now, we go to your y equal button, and on y2, let it be 0. Okay. So it's somewhere along here. Now, if you would like to see a graph a little bit more, you're quite uncomfortable seeing just use dotted line, you can extend your window somewhat to maybe negative 10. So that will give you a little bit of your graph below. You can see it a little bit more. If you're not happy with that, you can still see there back here, and maybe you can go back maybe negative 100, and that will probably give you a bit more detail. Although we do not want to go below 0 on the y-axis. But just to show you what. Now I need to find where it crosses the x-axis or the x-intercept. Press second trace and go to number 5. Press enter. Now first curve, we press enter, enter, enter. So 123.6. So it will continue here. I'm going to extend this graph. That's my t. 140. So we're on here. I'll take a ruler. So we know this point here is 123.6. So I'll make an indication for that. 123.6. Take a ruler. And now, because this is a restricted domain, there's no arrowhead beyond this point. It stops. Notice I put a dot, included dot here. It means it begins and ends here. So now we can put here. Now we put 140. That's our domain. Now we could go on there forever, so we can open this up. But a realistic one would be there. We stop there. Now, our range now is from 0, and it's stopped here at 1236. So this one here is definitely ends there. Because that's your height. That's your point you started to drop. That's the highest point of the balloon when you start to drop. So the maximum height. Maximum height, minimum height would be 0. And the way it's written in domain and range, you always begin from the lowest point to the highest point. So range from 0, the highest point is 1236. And you use your square bracket. Now, if it didn't touch 0, we use a curved bracket. If it didn't touch 1236, we use it be 0 to 1236 smooth bracket. But we didn't do that. And we'll stop here. Now you could continue this. In this case here, the range would be 123.6. Sorry, domain. Okay, that's where the balloon hits the ground. Okay, so what does the h-intercept represent? It's the initial height at time 0. At time 0, that's when the balloons start to descend, right? So we can say the initial height, or the height the balloons start to drop. Time 0, and the balloon begins to fall. So from here, 1236 meters, the balloon begins to fall. And it's falling until 123.6 minutes later, it drops to the ground. So after 2 hours, 3 minutes, and 6 seconds, the balloon reaches the ground. So the t-intercept represents when the balloon reaches the ground. So this is the ground level here. This is the ground. So we can see here the t-intercept, or in this case, the x-intercept, the time is in minutes. So time in minutes when the balloon reaches the ground. Now, how long does it take the balloon to reach 123.6 minutes? See that here. It's 123.6 minutes. No, the graph, now notice, right? Does the graph continue in both direction? No, right? It cannot continue because it only makes sense in the positive direction because the balloon cannot go back in time and it cannot go below the ground, right? So we can conclude only the positive values make sense, right? Only positive values for x and y works for this situation. And this is where you have to use your judgment as to what's realistic, because you cannot go back in time. Now, there might be a situation where if you're jumping off from the air and you go into water, you can still continue below the water level. And that's a different scenario. We'll look at that. What is the appropriate range? Here we have our range here. So we consider range, and we write square bracket. Our range would be from 0 meters to 1236. For those of you using Desmos, let's go over that now. Since we have completed it for Desmos users, I'm going to zoom in a little bit more because I can. It's a little smaller. For Desmos, it's less of steps. So first of all, we open our Desmos. We go with our y equals -10 x plus 1236. Okay. So there's our graph. Now, to see your graph now, you got to pinch and pinch and pinch until there's your graph. Okay. Now, to find your y-intercept, you tap, there's 1236, and your x-intercept, 123.6. Very much straightforward in your in Desmos. So all you need to do, your x and y intercept, the rest. Now, by the way, you can label your x and y axis. If you go, for those of you using Desmos, press your tap your tool button, and in your x-axis we have time. You can put here time. Okay, let's repeat that process again. You'll see a tool there, like a panel there. You touch that, and you change your x-axis here. Now, if you do that every time you have a graph, you'll have to change it. I don't recommend it, but if you're adventurous, you can put time here to label it. And open bracket, it's in minutes, right? So we type in minutes in there, close bracket, and our y-axis, we have height. And that's in meters, close bracket. And there we have it. And you can see, right, you have your height here in meters and time. It's a nice feature to have. Okay. Now you can set your windows to make it look more appropriate like this here if you go to your tool button, but it's not necessary. In this case here, you can set your range and domain. I can make that into 0. That's and leave that to, make that maybe 1300. Oh, I don't need to go that far because my x-axis, I make that 140. And for my y-axis, I can make that 0. And I can leave it like that. So now I have a more realistic. If you would like to set your domain and range. So if you would like to do it in Desmos, you touch your tool button and you can change your x-axis, label it. And you can also label your, I don't know, okay, it should be 0 here. Okay. All right, okay. So now, because it's labeling, so you'll see a little bit more of your negative and positives. So you touch again, y x-intercept, touch again your x-intercept. So it's much more straightforward using Desmos. Okay. Let's look at question 4. So Emil currently has $200 and spends $20 each week. So you have a function a equals 200 minus 20w, describe a spending pattern. So in this case, we have a, which represents the amount of money he has, right? So $200 he's spending, right? So this is what he started off with, $200. Right? If he didn't spend anything, it'll be amount of money, right, is equal to $200 minus he's spending $20 each week. So the rate of spending per week, which is $20, so you have negative because you're spending it, you're giving out the money or you're using it up. So you're not having this in your hand anymore. So you're spending. If you're spending, you will actually have a negative. Okay. So here we have draw the graph of the function. What does the variable w represents in this situation? What does the variable a represents? Okay. So a will represent the amount of money he has, right? So the amount of money, so we can see here, amount of money is equal to 200 minus $20 per week. That's how much he's spending per week. So let's label our graph here. So we have here, so the A, this would be like your Y is equal to your B minus your M times X. So your W becomes your X, and your Y is your A. So we can label this here as a week. So we can call this W instead of X. This is my X there. And the Y represents your A, amount of money. So we have amount of money. And we'll say that's in dollars. Now, you're starting out, domain will be 0 in weeks because you cannot go back into negative weeks, right? And you cannot have less than 0. Well, you could in negative, but in this case, we're looking at realistically, you're starting off with $200. Okay. So we want to find a range in domain. So that if you look at here, so if you look at our domain, again, would be from 0 here. We don't know where it will end, and the range, you know, is right from 0. And where the y-intercept is will be your ending. So this would be your y-intercept here. So we haven't gotten that yet. So let's try and see now. From here, my y-intercept is 200. So I know my maximum here should be above 200. So I'm going to make my y, which is my, let me put a y here in bracket. Well, I'm not calling it y, it's a. So we can make this an increment of maybe 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. So we have 200 up here. So we have 40, 60, 80, 120, we have 40, 160, 200. Now, I wouldn't know where this is right now. So what I will do, I will use my graphing calculator to figure that out, or Desmos. But let's go ahead and complete some of this. What does the variable W represent? They represent weeks, right? Because that's what we're talking about, right? Represent the number of weeks. So he's spending money, but we don't know how long it will take for him. Right, so we can have here, what does the variable A represent? The amount of money. So A, amount of money. Now the A-intercept, which we know from here is $200. That's the amount of money that he started off with, right? He has $200. So A represents amount of money. So amount of money, Emil started with. Or as we'll say, the initial amount. Initial means beginning. Oops. Now, when he spends all of his money, would be your y-intercept. Let's go ahead and get our graph so we can get our domain, a realistic domain. So this time I'll start off with Desmos. So I'll go back here. My screen, I'm going to clear this guy here. Oh, now by the way, now I have to go back and clear I'm going to clear these guys out. So I don't recommend you doing it because every time you have to change it. So we're going to change our equation. I'm going to remove, oops. Okay, so we have y. Remember, this is going to be y, so we can actually change it around. So I'm going to rewrite this as, let's make it look 200 minus 20x. Okay. And you can write it exactly as you see there in your, put it exactly as you see there in the calculator. Oops, I got this all straight here. So we have y equals 200 minus, notice you have a straight line, is a horizontal line, minus 20x. I need 20 here. And there's my graph. So notice, let's see, now our y-intercept is 200. So we know this graph starts from here and it ends after 10 weeks. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it ends right there. So here's my ruler. And your graph begins and ends at these 2 points here. So now we can write our domain is from 0 to 10, and the range is from 0 to 200. Now, if this graph were to continue forever, let's say if I put an arrow here, then the domain would be from negative infinity to positive infinity. And that's the curve bracket, same as the range. Or you can also have a different situation where one may be restricted, but in this case, there is a restriction, so we cannot write it in infinity form. Let's write this in the meter here. So weeks. Now I have my sketch, and another question: what does a y-intercept represent? That's when he has spent all his money. At this point here, he has no more money because remember, this is money. As you go along after the first week, how much you spend, second week, 8th week. So his money is declining until, so after 10 weeks, okay, the y-intercept represents, right? So the time in weeks, in this case, 10 weeks, when males spends all of his $200. In other words, you have no money left. No money left. And determine the value of W and A is 0. We know we already got that, which is 10 weeks. So when A is equal to 0, the amount of money W is equal to 10 weeks. $0, 10 weeks. Now, if you're using your graphing calculator, for those of you who are there, it will be the similar process. I just want to walk you through this case here. Change my equation here. I'm going to put that as, I'm going to get my equation here. I'm going to enter my equation into the calculator, which is 200 subtract. Now, by the way, because the slope now, it's after the y-intercept. In this case, I can press my negative subtract button rather than a negative one here. 20x. Now, I have to set my window, go back to my window here. I want my window to my x maximum to be, I can make that 12, make it a little bit, oops, 0 is our minimum. 0 minimum, your maximum would be, make that 12. Minimum is 0, and my maximum here is, I'll make that 220. It's a bit bigger. Oh, I'm going to put my equation now. Where is my equation? 200. Now, what did I do my window here? Oops. I have my scale here. Notice I change the scale, and I don't want to change the scale. I want that scale to be 1 still. Yeah, wrong input. Now, this might be a mistake you might make. You do not want to just change your scale. The scale means the incremental increase or change. Now, 1 represents it going up by 1. I could have done this when I'm going up here by 20, and that would be 20. For example, I want a y scale to be 20. I can make that 20 here. But my maximum here, I want it to be 220. And you will see those increment, same as here. Now find my y-intercept, which is 200, and my x-intercept. Now make sure I got y equals 0, go second trace, intersect. I'll go down to all the way down to the y-axis here. Sorry, the y-intercept, y-axis. Sorry, x-axis, not the y-axis here. I'll go down to my, press enter, 10, let's give you. So either method, you'll get the same result. We'll do the final question, which is the cost to rent a hall is given by the equation C is equal to 100 plus 5n. Draw the graph of this equation. Now this will be your y is equal to 100 plus 5x. So I'm going to change, see that? So I'll change the equation into a form that looks, one that we can work with in your calculator. So your C represents cost, you can tell you that here. And N represents number of party guests. Now, you may wonder, okay, how do I know which is X and Y? If it's written in an equation of a straight line form, as we have here, y equal to intercept form, y equal to mx plus b, your y is always what is equal to. So this could be cost. In this case, we have dollars. And because you're starting from 0, so your domain would be 0, and your range is starting from 0, and n represents number of guests. Number of and that will be, we call that n. So this would be C. So y now becomes C and our x becomes n. I can tell right away my intercept would be 100. So somewhere up here is 100. but I don't know my number of guests. So I'll have to enter this into my calculator. And I'll use a graphing calculator in this instance. So I'm going to go y is equal to, now I'll just enter this 100 here, plus 5x graph. Notice my window now, I don't want to go higher than 100 because it doesn't make any sense realistically. I'll change my scale back to 1. So maybe that 120, scale is 1. Now I don't know how long it will take, how many guests it will take for it to the cost. Okay, so we want to go maybe maximum, maybe put 100 here. Oh, and notice my graph is way over here on top. So now this is an increasing graph. The previous one we did was a decreasing, but now it's increasing. So now I have to increase my y values. I'm going to make that maybe 1,000. There you see a more realistic graph. So be careful. You have to play around with your window. So when that happens, you play around with your window. You said, how do I know? You'll know because your intercept will give you an idea where you should begin. If it's positive, the graph is going up. The previous one we did was actually the two we did earlier were negative, right? This graph was going down. This one is decreasing. But once we have a positive, it means if wherever your y-intercept is, it's actually going upwards. So it gives you a hint, right? So that's how I was able to determine. So now my range now will be really high. So now, if I look at my window here, I have my domain up to 100. Okay. And so we have our cost here. So C represents, let's look at some. So we're going to look back at the graph. So we label here as 0. So number of guests. So we have, so this can go on forever. So we have realistically in our window, we have 1,000 here, right? So we can make this maybe increment of 200. So we have 200, 400, 600, 800, 1,000, 1,200, 1,400. I don't know if this will be a realistic one until I answer the questions you asked, right? So now number of guests. Now we have number of guests 100. So I'll make that 200. Let's say we have 200 guests. What would happen? So notice that's my y-intercept. So the initial amount of money, that's your down payment more or less. So $100 is your down payment. That is your y-intercept here. So we have $100 right here. That's my beginning, and it's going up, increasing. And right now I have 200. So I'm going to make this here. This is 100, 200. Okay. And there's my graph. So right now, at this point here, I have my window at 1,000. So it will be about here. If I look, oh, that would be right around here. It would be my graph going upwards. So this would be my now notice I put an arrowhead means that this is going up, but there will be a limited number of guests. Right? So the place might say, look, you cannot have more than 200 guests in the building, and that will be our limitation of our domain. So our domain would be from 0, and the limitation here with number of guests can be accommodated in the hall, because you can only have a certain number of people in the hall, or else it would not be safe. And the range now, right, starting from $200 there. That's just your down payment. Generally, $100, not 200. Sorry. Generally, whenever you rent a hall, they'll say, look, you need a down payment. This is your down payment. So what does C-intercept represent? So the C-intercept represent the cost, right? The initial cost. The C-intercept represent. Okay, so here we have 100. Okay, number of guests here would be N. C, the down payment, right? So you have to, that's the amount of money, right? At zero guests, you have no money. I'm sorry, give them $100. So the C intercept, right, just here, represents the initial cost, right? So we said initial cost or the down payment. This is $200 here. So if you look at our calculator, let's find it right away here. Second, verify that. Second trace value x equals 0. Y is 100. Why am I saying 200 here? It's 100. Or the down payment. No, she's really a down payment would be our for rental hall, it would be your deposit, damage deposit sometimes. So we'll call it damage deposit. Or so more precisely, maybe I'll change it around. So it will be the initial cost for renting the hall with no guest. So you have no guests at this point here, right? Now, is there an N-intercept here? No, there's none. There's no N-intercept. Okay, so here the graph does not intercept the x-axis. Okay, so no N-intercept. Okay, we know the N represented the number of party guests, right? Okay. Does the graph continue both directions? No, only positive value makes sense, right? No. Now, the appropriate range for this one here, if you look at this question, you're actually looking and saying, okay, well, realistically, I would say most halls would be the maximum between 100 and 200. So I would say the domain appropriate range for this might be, now you're going up. If you look for 200, would be 100, minimum would be 100 for sure, to about $1,200, right? So maybe at 1,200 here. the range. And we're probably looking at a domain of maybe 200 guests. Right, so we can here maybe 200 guests here. Now this will make us 1100, right? Okay. So at 200 people, it will cost $1,100. So appropriate range would be from 100 to 1100. Okay, so we have our sketch, we have our graph, and we looked at domain and range, even though they didn't ask us for it. The last question I'll ask that you try out is quite an interesting question. If you're in physics, you would love it because it's using your graphic technology, you can solve this quite easily. So our goal today was to solve problems involving x and y intercepts of a linear function and to recognize limitation of the x values and y values in a contextual problem. The first question we looked at was one hot air balloon, and the balloon is descending. Whenever we're given an equation, we're trying to translate that into the y equals mx plus b equation so we can recognize our x and y labeling or representations. We use a graphing calculator to get a sketch of a graph and find our x and y intercept or Desmos. We also look at a way of recognizing the domain and range.